Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So let's say this is an absorption spectrum with lines n equals to 1, 2, 3, and 4, and we are given that we are given the difference of each the energy of each of this state from the ground state. So we have the energy difference from 2 between 2 and 1, which is 2.5. The energy, how much energy higher n equals to 3 from n equals to 1, and similarly for n equals to 4 and n equals to 1. And we are also given an ionization energy of 11.5 volt. So we know that ionization energy is basically the ground state energy. So E1 will be 11.5 volt. And now that we have all of the differences of energy, these are in units of electron volt. So E2 will be, and one more thing, the ionization energy is 11.5 volts, so E1 will be negative of this ionization energy. So yeah, now for n equals to 2, we can find the energy by adding this amount to E1. So E2 will be basically E1 plus 2.5 electron volt, and this gives the value for the second excited state to be negative 9.0 electron volt. Similarly for E3, this will be E1 plus 4.7, so we get that value to be 6.8 electron volt, and E4 will be 5.1 electron volt plus E1, so that will be 6.4 electron volt. So this is part A. Now for part B, we are given that a 5.1 electron volt photon is absorbed. So absorption of that, a 5.1 electron volt, represents a transition from the ground state to the third excited state, as you can see. So the possible photon emission energies now can be found like this. So they are as follows. So we can have a transition from 4 to 3, which is from 4 to 3. So the energy difference will be E4 minus E3. So that will be 6.4 electron volt minus 6.8 electron volt. And we get this value to be 0.4 electron volt. So we are finding these photon energies considering all the possible downward transitions that might occur as the electron make its way back to the ground state after being excited to the third excited state. That is, after being excited, observing a 5.1 electron volt photon. So yeah, so this is another possible transition. This will be 6.4 electron volt minus E2, which is, so there is a negative sign here, which I forgot. Yeah, so this is 9.0 electron volt. So the energy will be 2.6 electron volt. Similarly, we have 4 to 1, which is 6.4 electron volt minus is negative of 11.5 electron volt just by 5.1 electron volt. Then 3 to 2 minus what's the energy of E2? 9. So it will be 2.2 electron volt. Then we have 3 to 1. This is 4.7 electron volt. Then finally we have the first excited state to the ground state. So you can see that these values, I am starring them. We need to find these three because these are already given. But for conceptual clarity, I found them.